Prior to the first launch attempt, we live in this building, which is like a dormitory for those 3 or 4 days, practicing our last-minute procedures and getting fully prepared to launch. We launched at night on STS-93 based on the requirements that the Chandra Observatory had for its final orbit. We stop in the White Room on the way inside the orbiter to do some last-minute equipment reconfiguration, and here you see Eileen being strapped into the commander's seat. This happens about 3 hours before launch, and then as you can see, we count down to 0, the engine's light, and off we go.
The main engine start is about 7 seconds prior to liftoff, and the main engines come up to speed and are checked out to make sure they're good before we lift off. Katie will point out the small hydrogen leak that we had on the right nozzle. 3 of about 1,000 tubes were ruptured, which were enough to cause us a little leak, but not enough to cause any sort of failure in the engine or indication that it was failing. The liftoff is quite exciting, culmination of a lot of hard work by a lot of people around NASA. And the acceleration of the shuttle is testimony to that as it clears the tower at about 100 miles an hour. Proceeding on up and passing through the speed of sound nearly vertically at about 18,000 feet, approximately 1 minute into flight. The booster separated about 2 minutes. The shuttle continues to accelerate on the main engines to about 17,500 miles an hour in 8.5 minutes. When the main engines cut off, we're in 0G. We separate the tank, and we're orbiting the Earth.
About 1 hour and a half after ascent, we opened the payload bay door with Steve from inside the cockpit, and that allowed us to see Chandra outside. And after with Katie, we conducted the power-up of Chandra in order to have electricity and heating to the satellite.
We deployed the Chandra on day 1. And it's not just the Chandra telescope, but also the booster rocket that is attached to one end of the Chandra. You actually can't even see it behind the long silver telescope there. But in back of the telescope is the booster rocket, or the inertial upper stage. And much of our day 1 activities surround trying to check out the inertial upper stage, make sure that it is completely ready to take Chandra to its final orbit. And when some of the checks are complete, we go ahead and release the payload. And now we're going to actually tilt it up from the back of the bay. The top of the telescope is going to tilt up above the nose of the shuttle there. And this is a kind of an interesting shot where you're actually going to see the orbiter cabin reflected in the top end of the telescope. And so Jeff is actually using a camera to look out these windows, and you can see, you can't quite see Jeff filming, but you can see the 2 orbiter windows there. Now we tilt the telescope up like this so that we can go ahead and check out its lower antenna, make sure that that is functioning. It has an upper antenna as well, as we've already checked out. And we also do our final checks at that time before we release its umbilical, which is a series of cables and cords which provide power and telemetry from the telescope. And when we're sure that everyone is ready at Mission Control in Sunnyvale for the inertial upper stage, Mission Control in Cambridge for the Chandra, and also Mission Control in Houston for the shuttle, when we're sure that all those folks are ready, then I go ahead and pull the switch marked deploy. And you're looking at the deploy at the Chandra X-ray Observatory, 3rd in the series of 4 of the family of the great observatories. It's not something that moves out all that fast. It's about maybe 1 foot every 3 seconds or so. Now Eileen is getting ready to actually back the shuttle away from the Chandra, and we'll actually do a series of maneuvers to get away from the Chandra and the inertial upper stage before the inertial upper stage fires the first and then the second of its 2 solid rocket motors to then take the Chandra into its highly elliptical orbit, which is not close to the Earth as we are, but about 1/3 of the way to the Moon, so a very large elliptical orbit. This shows you as the telescope and the inertial upper stage pass by the upper windows there.
The Chandra facility was actually named after a very famous astrophysicist who worked in the 20th century and died about 4 years ago. His name was Subramanian Chandrasekhar, and that was all very hard for those of us in astronomy to say, but he was known among all of my colleagues as Chandra. And we deployed right before sunset, and this is the actual sun setting on the Chandra as we lost sight of it forever. Once the Chandra was deployed, we began to do some of the other experiments, and I showed you that telescope that we were practicing with in the simulator. This is a picture of Venus that we took with that telescope. This is actually one of the only pictures taken of Venus in the ultraviolet. This is a picture of Jupiter and its moons. Jupiter is so bright in this picture that its image is saturated a bit, but the little dots you see next to the bright image are the moons of Jupiter. And this is, of course, the Earth's moon. Again, ultraviolet lights don't penetrate the Earth's atmosphere well, and so you have to go to space to do this kind of observing, and that's one of the very few images ever taken of the moon in this wavelength.
As Steve mentioned, we had 20 other experiments on board besides the Chandra. This is one of several biology experiments where we took plants up to grow plants on orbit, and then I would take sets of those plants every 2 days and dissect them to bring them back to Earth for the experimenters to study. These were specially designed plants that had a gene designed into them that can actually tell the investigators back home if the plant was feeling stressed while it was on orbit. Stresses would include things like lack of oxygen, not knowing which way to grow up, things like that. And all these kinds of things, and these are some other biology experiments that you see attached to our mid-deck lockers, we're trying to understand how to grow plants in space, not only so that we can have food sources on our interplanetary missions, but also so that we can understand how plants grow, more about how they grow so we understand how to grow them here on Earth. And these are some of the other experiments, some of them very intricate single-cell experiments. And these are some caterpillars which turned into butterflies, which were studied by school children, and also some technology experiments. These are solar array hinges that we're trying out for new kinds of satellites and things that we'll try and have solar arrays on.
The shuttle has 2 engines that we use on orbit to raise and lower our orbit. You're going to see a burn here. We go from 0 G to a fraction of a G momentarily.
Living in space is exercising. You can see one of us running on the treadmill. We need to exercise every day. If not, you lose your muscle and your bones very quickly. And this treadmill will be on the space station. Eileen is, you see Eileen working with a computer to communicate with the ground. You have email on board, internet, and she's smiling because she received a letter from her husband. And you see the small kitchen on the right. So as a French, I was a cook in the flight. So, and they seem to enjoy. It's also exercising is cleaning. We have a vacuum cleaner, very similar to the one you use every day in your house. And you see Jeff with a cartridge. I mean, it's a system to reduce your CO2 or dioxide of carbon in your shuttle. And Steve is answering to a question asked by children through the computer, also by internet. Make some toys as well to study the conversion, I mean the momentum of the rotation for small things like that. And Jeff is a Navy pilot, so he wanted to play with water.
Well, the Earth is very beautiful, and it's tremendous to look out the window upon it, but that also is a job of ours. We spend a lot of time observing the Earth. One study we did on our mission was a study of the world's reefs. This is the Great Barrier Reef off of eastern Australia. It turns out that the coral reefs of the world indicate the health of the ocean, so they're being studied very carefully right now, and we're participating in that. These are 2 of the Society Islands in the South Pacific. We call that one Pork Chop Island. A view here of the lightning along the Texas Gulf Coast at night, and you can also see the band of atmosphere that surrounds the Earth. Very beautiful up there, but all things must come to an end. Fortunately, our mission ended with an empty tilt table, empty payload bay, and a successful deploy of Chandra. We did a deorbit burn here just before the sunset that you see here on the wing. A deorbit burn over Australia, and it slowed our orbit down enough to come bring the orbiter crashing into the Earth's atmosphere, somewhere between Hawaii and California. As we came across Texas, shown here from the ground in Houston, the orbiter was smashing into the air molecules and breaking them apart, forming a plasma glow and ion trail. Very spectacular from the ground. We're doing about 10,000 miles an hour at 200,000 feet at this point.
The long-range tracking cameras at Kennedy Space Center in Florida picked us up. This is our heat signature on an infrared camera. You can see how the nose and the wings are very hot. We heat up to over 2,000 degrees Fahrenheit. And in this shot, we're making a right turn to land to the north. This is the actual view that Jeff and I saw out our forward windows. The numbers are on a heads-up display or a HUD. In the background, you see Cocoa Beach and Cocoa as we, again, turn around to the north. You can read out our altitude on the right, our airspeed on the left, and we have a guidance diamond in the middle that we follow to keep us on course and glide slope. We're 300 knots at this point, descending down final on about 7 times higher descent rate than a commercial airliner. In this view, we're passing 2,000 feet. We're doing a pre-flare maneuver to take us to a 1-degree glide slope. And again, this is the picture we saw with the floodlights. We were only the 12th night landing ever, and night landings are a little more difficult. Obviously, you don't have the same depth perception or sense of speed at night, but the lights brought us in. Jeff deployed the landing gear at touchdown. He deployed the drag chute. And it was actually quite easy landing the shuttle after having trained for many years in the shuttle training aircraft that we maintain to keep the pilots' skills up to actually come in and land. And every shuttle mission has been landed manually by the commander versus an auto land. We stopped the orbiter, did about 30 to 40 minutes of reconfiguring to get Columbia ready to turn back to the ground crew. And we got out, did a walk around, met the folks at Kennedy Space Center. This is a really special time for us to thank the workers for getting Columbia ready. You'll see a picture here of the right main engine. We had talked about our hydrogen leak, and you'll actually see it here. It was very small, but you can see as soon as the folks saw that after we landed, they had a pretty good idea of what had happened.
And off we go.
The main engine start is about 7 seconds prior to liftoff, and the main engines come up to speed and are checked out to make sure they're good before we lift off. Katie will point out the small hydrogen leak that we had on the right nozzle, 3 of about 1,000 tubes.
Prior to the first launch attempt, we live in this building, which is like a dormitory for those 3 or 4 days, practicing our last-minute procedures and getting fully prepared to launch. We launched at night on STS 93 based on the requirements that the Chandra observer
Were ruptured, which were enough to cause us a little leak, but not enough to cause any sort of failure in the engine or indication that it was failing. The liftoff is quite exciting, culmination of a lot of hard work by a lot of people around now.
laboratory had for its final orbit. We stop in the White Room on the way inside the orbiter to do some last-minute equipment reconfiguration, and here you see Eileen being strapped into the commander's seat. This happens about 3 hours before launch, and then as you can see, we count down to 0, the engine's light.
NASA. And the acceleration of the shuttle is testimony to that as it clears the tower at about 100 miles an hour. Proceeding on up and passing through the speed of sound nearly vertically at about 18,000 feet, approximately 1 minute